Today we'll be talking about one of the most fundamental concepts of chemistry, the mole. Let's begin. Have you ever wondered how many atoms are there in your body, an egg, or a piece of pencil lead? Well, atoms are really small, so you're probably guessing a lot. But just how many is a lot? One piece of pencil lead, there are 2.056 times 10 to the 21st carbon atoms. That's a lot of zeros. Since even the smallest objects contain a lot of atoms or molecules, we count atoms and molecules using a counting unit called the mole. The mole is a word that stands for a number. Just like dozen is a word that stands for 12, the mole means 6.022 times 10 to the 23rd. If you have a dozen eggs, that means you have 12 eggs. If you have a mole of eggs, that means you have 6.022 times 10 to the 23rd eggs. Whoa, that's a lot of eggs. 1 mole of chicken eggs would cover the entire Earth 14 miles deep. So I told you that there were 2.056 times 10 to the 21st carbon atoms in a piece of lead, but how did I get to that number? Since atoms are too small to count, scientists measure mass or volume of atoms. They use a technique called dimensional analysis where they use conversion factors to switch between units while still describing the same value. For example, if the pencil lead has a mass of 0.041 grams, you can calculate the number of carbon atoms in the pencil lead using conversion factors. The first conversion factor we need is the mass of 1 mole of carbon. To find the molar mass of carbon, we look at the periodic table to find its average atomic mass. Since the molar mass is the same as the average atomic mass, 1 mole of carbon is equal to 12.0 grams of carbon. So we can write that in fraction form. You can either write the mole on the bottom or the mole on the top, grams on the bottom or grams on the top. These just two mean that they're the same thing. They equal to 1. The starting value is 0.041 grams of carbon. To switch from grams of carbon to moles of carbon, you multiply grams of carbon by a conversion factor. When the bottom units are the same as the starting units, they cancel out, leaving the U unit moles. So you can see here that grams cancels out, and our new unit at this point is 1 mole of carbon. Since we know 1 mole is always 6.022 times 10 to the 23rd atoms, we can now calculate the atoms of carbon in the pencil lead by multiplying it by another conversion factor that switches it from moles to atoms. So again, these two equal the same value. In 1 mole of carbon, there are these number of atoms. This number is a good number to memorize. It goes by the name Avogadro's number. This will always stay the same. It will never change, no matter which element you're working with. The second conversion factor cancels out the mole units and makes the final unit atoms. So this is the final equation setup. We canceled out the grams, we canceled out the moles, and finally we left with atoms, what we wanted. Can you use the conversion factors to calculate the number of atoms or molecules in different objects you find at the carnival? So this is where you'll be able to get in some practice working with moles. So select an object and use dimensional analysis to solve for the number of moles. So we're going to be working with moles. There's various here. Let's do one of these together. A balloon is filled with 8.964 liters of helium at STP. How many moles of helium gas are in the balloon? STP simply stands for standard temperature and pressure. When we say STP, just means that you don't have to worry about what the temperature in the room is or what pressure the balloon is under. We can just work with what we're given. So here we have 8.964 liters of helium. I'm going to type that number here. And I'm going to click the unit. So they said liters of helium. Liters is also written in a capital L. So now I want to find the conversion factor. We want to go from liters to moles. So I want to make sure that my conversion factor have both those units. This one has moles of helium and grams. We don't want to change it to grams, so we can go ahead and move on to the next one. Moles and atoms. We're not looking for atoms. Let's move on. Mole and liters. That's what we want. We want to go from moles to liters, and this we want to do helium. You'll notice that this one is similar, but this one just says gas. If you weren't given helium and you just were given liters of gas, this conversion factor would be okay. But since we know the gas we're working with, we're going to use this factor. So we can see here that we put it in the correct position. Liters are on the bottom. They'll cancel out and you'll get moles. You'll see here how the equation is set up. This multiplied by 1 over 22.41 is just like dividing. So if you were to put this in a calculator, you would type 8.964 divided by 22.41. And it'll give you your value of 0.4 moles of helium. You can always do this backwards. Say you started with 0.4 moles and you wanted to get to liters. You would have to switch this conversion factor so that the mole was on the bottom and that the liters were at the top. So you can go back and forth with these equations. They'll work the same. So go ahead and try these out. I'm going to link the simulation below. I'm also going to link some other articles and videos that might help you out. Moles can be a pretty tricky subject to learn, but it's a very important one to grasp for chemistry. So if you have any questions, again, feel free to ask, and good luck!